Bruce Heilberg. I'm a research specialist for American Roller Company. I've been in product development for 35 years. And today I want to talk about insulating and conductive materials. I try to simplify to explain the difference between conductors and insulators. And I find that there are a number of terms that are used in the industry that confuse customers. Conductors are actually low resistance. Insulators are high resistance, but some customers refer to insulators as high insulating or low insulating, or highly conductive or low. And sometimes when customers actually are trying to specify a material to me, they actually mean the opposite of what they say. So in order to simplify it, this is a chart and it's all based on resistance. So conductors are low resistance, insulators are high resistance. And to understand the terms that are used here, we need to talk about Ohm's Law, which defines the relationship between voltage, amperage, and resistance. Amperage is flow, resistance is ohms. So if you know one of the quantities, you can calculate the other one. So in the simple example, a light bulb, and this is a special light bulb that only operates at 100 volts, draws 1 amp, and it has a resistance of about 100 ohms. Some materials here I want to show. Just some common things. This is some nickel chromium heater wire. It has a resistance of about 2 or 3 ohms for 10 feet. 25 watt soldering iron is about 600 ohms. And this is a heater which is very similar to the heater that might be in your oven. It's a 700 watt heater. It has a resistance of about 20 ohms. So, but I can't make rubber compounds into wire to measure them, so how do we measure materials that can't easily be made into wire? So the way we do that is we take a 1 centimeter cube of the material and put a metal electrode, which is just a plate, on either side, and then we measure the resistance between the two plates with some sort of resistance meter. There's a number of materials listed on here. If we measured them according to the cubic centimeter type of test, some of the best conductors would be like gold and silver. You know, all your metals are down in this area, and the resistance in ohms of these materials is extremely low. It's about 1/1,000,000th of an ohm for the cubic centimeter. On the other end of the spectrum, we have insulators that are really good insulators. Various types of rubber, silicone, Teflon, and the resistance is 10 to the 15th ohms, which is 1 with 15 zeros after it. I don't even know what number that is, but it's 1,000 trillion. It's a big number. So there's a huge range between what conductors and insulators are. And then we have materials that are semi-conductors, and they are typically in the 10 to the 4th, 10 to the 8th ohms range, which is 10,000 to 100 million. Okay, so we have this huge range of resistance for various materials. And why is this important? Well, resistance is an important property for certain applications. And materials that are highly insulating, like this group up here, can be used for chronotreater rollers. The best insulators that are available are used for chronotreater rollers. This group here, this very narrow range, is used for electrostatic assist gravure printing rollers. And then this range here is used for conductive or anti-static rollers. So next time we'll talk about this particular range, how those anti-static rollers can be used in production.